Tonight we're discussing or going over a rather interesting result, even though the proof is pretty easy, and it deals with this notion of greatest common divisor. I've heard it called the greatest common factor. Now, it's often represented just like an ordered pair, actually. It's nothing to do with an ordered pair. This reads the greatest common divisor of the integers 15 and 6, all right? That's the greatest common factor. Some people call it that. In this case, it's equal to 3. 3 is the largest natural number that divides both 6 and 15. Okay, so that's the greatest common factor. Some people will put GCF out front, something like that. Now, also, just while we have it up here, and it's going to be useful for what we're trying to establish tonight, if you have 15, comma 5, the GCD of that, the greatest common factor, greatest common divisor of 15, comma 5. Okay, in this case, answer's 5, because 5 certainly divides itself, and 5 is a divisor of 15, so it's equal to 5 right here. Okay. So again, I suspect most of you are very familiar with this, but just in case. All right. Now what we have here is a system of equations that involves the greatest common divisor symbol. All right. And we're supposed to show that this system of equations has a solution whenever a squared divides b. Okay. Now, y'all, that just means a squared is a factor of b, or b over a squared is a natural number, an integer. Now, let's just write down exactly what that means. It's fairly easy. This result just follows almost immediately. There's nothing deep going on here. A squared divides b if and only if b is equal to k times a squared. In other words, a squared is a factor of b. It's the same thing as saying is a squared divides b. Also, this statement would tell us that k divides b, even though it's not important for this particular, what we're trying to show here. Now, let's move on down and let's look at the original system here. So, note, here's our original system, but we know that b is equal to k times a squared based on this given right here, okay? And so we can rewrite this system, replace b with k times a squared. Now notice here that makes the solution just really stand out right here. This tells us just very quickly that we need to choose x to equal to ka. So that's the x portion of the solution, ka. X equals ka. And you know, I'm going to do my best to, my lame a sometimes looks like an o, but that verticalness hopefully will convince you that is a ka. And also we'll pick y to equal to a. Okay, and so it's very clear that if you put ka right here and a right there, the GCD will be a in a fashion similar to how the GCD of 15 and 5 is 5 itself. Very same thing right here. If we take x to be ka, well, it'll land right there. Y to be a, we satisfy this GCD condition, and also trivially we satisfy this condition. So we do have a solution here. This is a solution. And we've proved what we set out to prove. Again, nothing heavy happened there other than just knowing what the symbols meant, okay? Now, this is a concrete example down here where you can make a little more sense out of it. Notice right here, what would we need right here? We would choose x to be what? Okay, x would have to be 30. And y would be 6. All right. And again, it's pretty obvious, but it is necessary, I think, and sufficient. You need the square divisor, I believe, for this equation to have a solution. I think it's an if and only if. So anyway, it doesn't seem like much, but apparently for this type of equation, I guess I did an if and only if for you. I'm not sure really. But anyway, this system has a solution, I'm claiming, if and only if a squared divides b. Hope you enjoy.